It says ZX, ZY, and ZW are perpendicular bisectors of triangle TUV. Find XT, VU, and ZV. Now remember, perpendicular bisectors, where they intersect is called the circumcenter. So you're going to have to remember this. So where they intersect is the circumcenter. So this right here is our circumcenter. And I'm going to go ahead and put a C next to it so we remember that. And if you remember, your circumcenter theorem says that if you connect the circumcenter to each of the vertices, then those segments will be congruent. So this segment, the one that goes from the circumcenter to the vertice, this one as well is congruent, as well as this one from the circumcenter to the vertice. So these three segments are congruent because of the circumcenter theorem. They're asking me to find XT, VU, and ZV. So they want me to find XT, this right here, VU, this whole length right here, and ZV, so from Z to V. Okay, well, let's go ahead and talk about this line right here, ZV. Notice it has that congruency marking that we said would be congruent to this line and this line. They're telling us right here that ZU is 20 units, so that means that ZV here has to be 20 as well. So we found the length of ZV, which is 20. Next, these sides over here. Now, let's go back to the problem. It says here that these lines, ZX, ZY, and ZW, are perpendicular bisectors. What that means is that they are perpendicular to the sides. So I'm going to go ahead and mark these as right angles. And they're bisectors. Remember, bisect means to cut in half. So they cut the sides in half. So these two are congruent. These two right here are congruent. And then these are congruent as well. So if we take a look here now, I can say that the length of XT is the same as UX. So XT is 16. And over here on the left side, we want the length of VU. Notice these two sides or segments are congruent. So this part from V to Y has to be 15. So the whole length from V to U has to be 30. If MX is equal to 21.6 and LZ, or find LZ and MW. So all they've told me is that MX, this whole line right here, is 21.6. So that's this whole line. Okay, not just part of it, the whole thing. Now, it didn't tell me what kind of lines these are. I don't know if it's perpendicular bisector, altitudes, medians, or angle bisectors. So I'm going to go ahead and take a look and see what I have. Looks like on the sides they got bisected. And so that tells me that this is a midpoint. And it's going from the midpoint to a vertex. If you take a look at your different intersecting lines, the only one that goes from a midpoint to the opposite vertex are your medians. So I know that I'm dealing with medians. And where the medians intersect is called the centroid. Remember, this is the center of gravity. So this right here is the centroid. And we do have a centroid theorem. The centroid theorem says that from the centroid to the vertex, that length is 2/3 of the whole line. So right here, KW would be 2/3 of the length of this whole line, KY. So if you want to go ahead and look that up in your book, you can. It is your centroid theorem. So if they told me this whole line right here is 21.6, I need to find LZ and MW. So LZ, they want me to find this whole length all of this side. Let's color that green. I want L to Z. And they want me to find MW. So just this part right here. Okay, so in median, because our theorem says that this right here is 2/3 of the whole line, that means that this part right here is going to be 1/3. Now, in the denominator of each of the fractions I just said is a 3. So if we can divide this length into 3 parts, we can figure out how many parts each segment needs. So I'm going to go ahead and start that first. I'm going to do 21.6 divided by 3, and I get 7.2. That means each third, so each third is equal to 7.2. Now remember, the theorem says that this part from the centroid to the vertex is 2/3 of this whole length. I know what 1/3 is. If I need 2/3, then I need to double this length right here. So 2/3, all I need to do is multiply that, is 14.4. Now, this is not the only way to do it. You could have, and whichever one you like, you need to stick with, you could have said, okay, the theorem says 2/3 of the whole length is equal to MW. Okay, so find the method that you prefer. You will get the same answer. Just make sure you remember which part is 2/3, which part is 1/3. So here you're going to get 14.4. Same answer. Okay, so MW is 14.4. Let's go ahead and put that in here. Next, right here, they want us to find the whole length of LZ. So this whole length right here. Now notice this part goes from the centroid to the side. This is the part that we said would be 1/3. To find the whole thing, this other part right here, if you remember, this is 2/3. That means I need 2 of these to get this longer segment. So if I double this, I know that from W to L, it is 12.2. So the whole segment, all I need to do is add those together. And I get that the length of ZL, or LZ, is equal to 18.3. So for centroids and medians, you have to remember which one is 2/3. It's the one from the centroid to the vertex. That will always be your longest segment. That one is always 2/3 the length of the whole. And the one that goes from the centroid to the side, this is 1/3. And remember, there's 2 different ways you can figure out by dividing the whole line into 3 parts so you can see what each third measures. Or if you want to plug it into the formula, but you've got to remember which part goes where in your formula. Find the coordinates of the orthocenter of the triangle. Now, orthocenter, if you go back and remember, orthocenter is where the altitudes intersect. And another word for altitudes is height. Whenever you measure of height, you want to stand up straight at a perpendicular to the ground. Okay? So if I were to measure the height of this triangle, I want a perpendicular segment from the top to the bottom. The first one I'm going to find is the one that goes from this top to this bottom. It's the easiest one. This is already a completely straight line, so if I wanted to find a perpendicular, I would just have to go directly this way. Okay, this is a right angle down here, and it is perpendicular, and it goes to a vertex. Your altitudes always go perpendicular from a base directly to a vertex. Now the other two, this is where the harder part is, because you can't just draw a line and assume it's a right angle. You're going to actually have to find the slope and then get the perpendicular slope. Remember, to find a perpendicular slope, all you have to do is flip your original slope and change the sign. So I'm going to go ahead and do that one on this one. First, I'm going to find the slope. Okay, so the slope is, I'm going to go up, rise of 1, 2, 3. And I'm going to run over 1, 2, 3, 4, 5, 6. Okay, so if I reduce this, this is a slope of 1/2. Now I want a perpendicular slope because I need this to be perpendicular. Your altitudes are always perpendicular. So I need to flip this. So now I have 2/1. And since he was positive, he needs to be negative. Remember, I need that altitude to go through this line right here. I just found the slope of this line. And it's going to go through this point right here. So if I start counting from here, I need a slope of -2/1. So that means I'm going to go down 2 to the right 1 from here. So down 2 to the right 1, down 2 to the right 1. You can kind of see where that line's going to go through. Let's go ahead and connect those and draw our altitude. So that right there is perpendicular to this line right here. So now when they're asking us to find the coordinates of the orthocenter, I don't need to do this other line because I can already tell where these points are going to intersect. They're going to be intersecting right up here. And we can just write the coordinates. It's not necessary to find all three. So the coordinates here are -1, -2, -3. It doesn't go to -4. Looks like we're at -3.5. And we're up at 1, 2, 3, 4, 5. Okay, so the coordinates of our orthocenter are at -3.5, 5, where our altitudes intersect. Next, number 18. In triangle ABC, B is on the perpendicular bisector of segment AC, and the measure of angle A is 6x plus 14, and the measure of angle ABC is 10x minus 2. Find the measure of angle C. So first off, let's go ahead and draw this so that we know what it looks like. We're not exactly sure how this triangle is, so we're just going to draw a random triangle. And it's called triangle ABC. And it says B is on the perpendicular bisector of segment AC. So this segment right here is getting bisected, and that bisector goes through point B. So it's going to look something like this. This is at a right angle, and this got bisected. And they told us that angle A is 6x plus 14. And the measure of angle ABC, so these two angles together are 10x minus 2. Find the measure of angle C. They want us to find what this angle measures right here. Now, if you take a look here, this is from section 1. Notice we have a perpendicular bisector, and if you remember your perpendicular bisector theorem, we know that this segment and this segment right here are congruent. And so since they're congruent, we know that this is an isosceles triangle. If I look at the whole thing, that means this angle is also 6x plus 14. And if you remember, the sum of all three angles in a triangle is 118. So we can go ahead and add all these three angles and set them equal to 118. So we have 6x plus 14 plus another 6x plus 14 plus 10x minus 2 is equal to 180. Okay, let's go ahead and simplify the left side. We have 6x plus 6x is 12x plus 10 is 22x. 14 and 14 make 28 minus 2 is 26. This is equal to 180. We can subtract 26 from both sides and get 22x is equal to 154. And when we divide by 22, we get that x is equal to 7. So now that I know that x is 7, I can go ahead and plug this back into angle C and find the measure of this angle. So 6 times 7 is 42, plus 14 is 56. So the measure of angle C is equal to 56 degrees. Find the coordinates of the centroid of the triangle with the vertices at -8, -4, 2, 4, and 6, 3. So let's go ahead and plot these points here. For our first one, we have -8, -4, which is right here, 2, up 4, and 6, up 3. Find the coordinates of the centroid of the triangle with the vertices at -8, -4. So let's go ahead and plot this. 2, 4, and 6, 3. Now, if you remember, centroid is the point of the intersection of your three medians. Okay, so I need to find the medians. If you remember, your medians go from the midpoint of the side to the opposite vertex. So that means I have to find the midpoint of the sides and then connect that midpoint to the opposite vertex. So we're going to be using the midpoint formula. And once again, midpoint formula, if you've forgotten from the previous problem, is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now, if you remember, we had a video where I showed you how to find the midpoint by using slope. We're going to go ahead and use slope, but if that doesn't make sense, you can go ahead and use your midpoint formula. If I take a look at this segment right here, I'm going to find his slope. His slope is rise 1, run to the left 4. Since I want the midpoint, I'm going to do half of what that slope was. Now remember, the slope was that I was going to go up 1 to the left 4. Instead of going up 1, I'm going to do half of that. So I'm going to go up a half. Instead of going to the left 4, I'm going to go to the left 2. So this right here is my midpoint. Okay, I took the slope and I did half of what I'm supposed to do for the slope. So now I have that midpoint there, and I'm going to go ahead and connect that to the opposite vertex. And I'm going to go ahead and find the next midpoint. And I can find it of this side or of this side. And I'm going to do the same thing I did before. I'm going to count the rise and the run. So from here to here, I'm going to rise up 1, 2, 3, 4, 5, 6, 7, 8. So I went up 8. And I'm going to run over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I don't want to reduce this because this tells me how much I went up and over. But I'm going to do half of what the slope is. Instead of going up 8, I'm going to go up 4. Instead of going to the right 10, I'm going to go to the right 5 units. So I'm going to go up 4, 1, 2, 3, 4, and then to the right 5 units. 1, 2, 3, 4, 5. So this right here is the midpoint. And when I connect that to the opposite vertex, which would be this one right here, I've created the median. Now notice my two medians already intersect. It is not necessary to find the third median because we know it's going to go through this point right here. This is my centroid where the medians intersect at. They want me to find the coordinates, and the coordinates of that that centroid is 0, 1. So this is the centroid. And we used our slope, and we just did half of what the slope did to find where these midpoints were. It says here TG and VG are angle bisectors of triangle TUV. Find the measure of angle VGT and the distance from G to UV. Okay, now you got to remember your angle bisectors, where they intersect is called the incenter. Remember, the incenter is always inside the triangle. Also, the incenter theorem says that the incenter is equidistant from the sides. Okay, so you've got to remember that for angle bisectors. So since I was told that TG and GV are angle bisectors, then I know that this angle here is congruent to this angle. And I also know that this angle right here is congruent to this angle over here because they're angle bisectors. So knowing that, I'm going to go ahead and fill in the missing information. That means this is 33 degrees and this is 39 degrees. They want me to find the measure of angle VGT. So angle VGT. They want me to find this whole angle right here. Okay, well, taking a look here, if you notice, I have this triangle forming right here. I know two of the angles of this triangle. I just need to find the third angle. So since I know two of the angles, all I have to do is add them up and subtract it from 180. So by doing that, if we have 180 and then subtract 39 degrees and subtract 33 degrees, we get 108 degrees. That means that angle VGT has to measure 108 degrees. And that's just by noticing that we have this triangle right here. Notice there are a lot of triangles. You just have to be able to recognize which one to use. Next, they also want me to find the distance from G to UV. So from G to UV, looks like they already have a line drawn for us right here. Now, if you remember, we talked about the incenter theorem. We said that the incenter is equidistant from the sides. What that means is that the incenter, this point right here, is the same distance from all three sides. So if I created this line right here that's also perpendicular, these would all be congruent. Since they're all congruent, then I can set this equal to this right here. So now I have 3x plus 6 equals 5x minus 3. If I subtract 3x, I get 6 equals 2x minus 3. And then when we add 3, we get 9 is equal to 2x. And then we divide by 2, 4.5. And I can use that and plug it in here so that I can find the distance from G to UV. So when I plug it in, 5 times 4.5 minus 3. So this is the distance from G to UV. Find the center of the circumscribed circle formed by the following coordinate points. Now the circumscribed circle, if you don't remember, is formed by first finding the circumcenter. The circumcenter is formed by the three perpendicular bisectors. So first I have to find the perpendicular bisectors, and when I find those, they are going to intersect at the circumcenter, and the circumcenter is the center of the circumscribed circle. I know it's a lot of information. Find a way to memorize it and remember which one goes with which. Now, the incenter creates the inscribed circle. The circumcenter creates the circumscribed circle. Okay, so make sure you know which one is which. Let's go ahead and plot this. We have A at -4, -5. And we have B at -4, +2. And C at 4, -5. So here is what our triangle looks like. Okay, so first we must create our perpendicular bisector. And since we have a complete vertical and horizontal line, finding the perpendicular is not going to be too hard. Let's go ahead and start with AB. To create a perpendicular line, we just need a horizontal line. But we need to bisect this segment. Right now the segment is 1, 2, 3, 4, 5, 6, 7 units. So to bisect that, I need to go 3.5 units up. So 1, 2, 3.5 right here. This is the bisector. That means this segment is congruent to this segment. And if I want to draw that perpendicular line, we're going to go complete horizontal. This is my perpendicular bisector. Creates a right angle right here. Okay, let's go ahead and find this perpendicular bisector. And I want to do these two because they're the easiest ones. This right here measures 1, 2, 3, 4, 5, 6, 7, 8 units. So the bisector is going to be at the 4 unit. 1, 2, 3, 4 right here. So now I know this segment is congruent to this segment. And I can draw my perpendicular bisector. We know it's going to be vertical. And where they intersect is right here. This right here is the circumcenter. And we know that the circumcenter is the center of the circumscribed circle. So this coordinate point is what they're asking me to find, which is at 0, comma, negative 1.5. Okay, so if you want to see what the circumscribed circle is going to look like, this is its center, and the circumscribed circle touches all 3 of the vertices of the triangle. So if we draw this out here, this right here is the circumscribed circle. You can see these vertices are on the circle. Okay, the inscribed circle is going to be inside the triangle. The circumscribed circle is outside, and it has all 3 vertices on the circle. So this is how you can tell which one is which. Find AB. If you look here, we're told that this line XB is a perpendicular bisector, and that means that it intersects at a right angle and it bisects AC. And we know by our perpendicular bisector theorem that these sides are now congruent. So I can go ahead and mark these now. And since they're congruent, I know these are going to be equal. So we can have 8x minus 8 is equal to 6x plus 2. So let's go ahead and solve. If we subtract 6x, we're left with 2x minus 8 equals 2. And then when we add 8, we get 2x is equal to 10. And then when we divide by 2, I get that x equals 5. Now, notice the question says find AB. So I have to go take this and plug it in here. Okay, they did not ask for the value of x. They wanted the side AB. So make sure you read the question carefully. So 8 times 5 minus 8. 8 times 5 is 40, minus 8 is 32. So length AB is 32. Find the measure of angle DEY. So let's go ahead and see which angle they want. DEY, that's this angle right here. Here we have these segments right here are perpendicular to these rays, and they're also congruent. And this is still from section 1. So because we know they're perpendicular and congruent, we know that this right here is an angle bisector, which means both of these angles are congruent. So I can set these equal to each other. So I have 12x minus 3 is equal to 9x plus 6. And then we can solve. We can start by subtracting 9x to both sides. We get 3x minus 3 is equal to 6. And then add 3 to both sides. We get 3x equals 9. And then divide 3 to both sides, and we get x is equal to 3. Once again, they want angle DEY. They don't want the value of x, so we have to take this and plug it back in. So 12 times 3 minus 3. 12 times 3, that's 36. And then when we subtract 3, we get 33. So angle DEY is 33 degrees. Find the measure of angle QSP. So angle QSP, that's this angle right here. All I know is that this angle right here is 35 degrees. And if you notice here, this side is bisected, R is the midpoint, and so is this side, Q is the midpoint. That means this line right here is our mid-segment. And if you remember, our mid-segments are parallel to the base it corresponds. So this line is parallel to this line here. And because they're parallel, we know that this angle and this angle is congruent because they are corresponding angles. These would be your parallel lines, and this would be your transversal right here. So this angle would be 35 degrees. So now here we see another mid-segment. So that means this line is parallel to this line, and we have a transversal right here. Notice these two angles are called same side interior angles. And if you remember, your same side interior angles are supplementary. So 35 plus this angle right here, we're going to call them x, has to equal 180 degrees. So if we subtract 35, we get that x is equal to 145. Problem 7, find the value of x. So here, if you notice, these two are midpoints. We know that because these two segments are congruent. So this is a mid-segment, and this is the side it corresponds to. And if you remember your mid-segment theorem, this right here is half of this length, or you could say this right here is twice as big as this length. So it's going to take two of these to create this. So I need x plus 5 plus another x plus 5 to equal this side right here, 10x minus 6. So now we can solve here. I have x plus x is 2x. 5 plus 5 is 10. Haven't done anything to the right side. I'm going to go ahead and subtract 2x from both sides. I have 10 is equal to 8x minus 6. And then I'm going to add 6 to both sides to get 16 is equal to 8x. And when we divide by 8, we get x is equal to 2. And that's all they're asking us to find. Find the value of x. They do not want us to go ahead and plug it back in. So we're done. Okay, for questions 5 and 6, we're going to use the same figure here. So it's asking us to order the sides of triangle KLM, so this triangle right here, from shortest to longest. So in order to do that, we need to know what the measures of all three angles are. This one is 68 degrees. This one's 37 degrees. We know that the sum of all three angles must be 180 degrees. So 180 minus 68 gives us 112. Then if we subtract 37, we're left with 75. So this right here has to measure 75 degrees. Now if we look here, we want it from the shortest to the longest. The smallest angle is 37. That means this is my shortest side right here, side KM. Next would be 68, and across the 68, KL would be the next one. And the biggest angle is 75.
that means this side, ML, is my biggest side. Okay, for number 6, it says find the range of values for x. If we look here, you know this angle is 32. This side is 2x minus 12. Let's go ahead and erase this here. Over here we're told that this side is 8, and it's across a 37 degree. If we compare these two angles, 37 is bigger, which means 8, this side right here, is bigger than what this side measures here. So I'm going to go ahead and set an inequality. We said 8 is bigger, so side KM is bigger than this side, 2x minus 12. So that's our first part of the inequality. If we add 12 to both sides, we get 20 is greater than 2x. And then when you divide by 2, we get x is less than 10, or 10 is greater than x. Now that's our first inequality. Now we need the other part. We need our lower bound. We know that this side right here must measure greater than 0. So our next inequality, we're going to do 2x minus 12 greater than 0, because it measures more than 0. So if we add 12 to both sides, we get 2x greater than 12. And then when we divide by 2, we get x is greater than 6. So the range of values for x is 6 is less than x is less than 10. So first you set up your inequality comparing the two triangles. Then whatever that angle or side measures, we know it has to be greater than 0. So that's where you get your second value from. Is a midsegment. So they went ahead and told us that this right here is a midsegment. So knowing that, I know that this is congruent to this, and this guy is congruent to this side. And they also told us HK is the midsegment. So this guy right here is the midsegment of this triangle right here. So we have a midsegment and another midsegment within the triangle. So I know that this side is congruent to this side, and this side is congruent to this side right here. So let's go ahead and fill in something that can help us. If this is 7, and we're told that this is a midsegment, then that means this side right here is also 7. And so far, that's all I can say about it. But I went ahead and wrote it down to see if it would help me in the future. It's asking us here, what is the length of HK? So the length of HK is this right here. This is what they want us to find, this midsegment. Well, I know from what I've been told that this side, DG, is 2n minus 1. And this right here is a midpoint. And we said that this is congruent to this side right here. And if you look, this side right here, if we do 7 plus 7, measures 14. We know that DG is congruent to GF. So we can go ahead and set up our equation. This part right here is congruent to this part right here. So 2n minus 1 is equal to 14. So let's go ahead and solve. We add 1 to both sides, we get 2n is equal to 15. And when we divide by 2, we get that n is equal to 7.5. So they want us to find the length of HK. We're going to need to plug this back in somewhere because all I know is that this is n. There's nothing here at HK that I could plug this into, so let's go ahead and plug it in here. If I can find out what this is, I can divide that in half to find this midsegment. And here's another midsegment. We can divide that in half again to get this value here. Now if we plug this in, we have 2 times 7.5 plus 1. So if this is 16, the mid-segment would measure half of that, which would be 8. And HK here is the mid-segment, so if this is 8, this would have to be 4. So we can say that the measure of HK is equal to 4. Find the range for the values of x. So this one is just like number 9. If we take a look across each one of these angles are the side measures. 42 is smaller, so that means that 6x minus 18 is smaller than, he's less than, the angle that measures 4x plus 2. So now I have the first part of my inequality. I can go ahead and solve this to get part of my range. If I start off by subtracting 4x from both sides, I get 2x minus 18 is less than 2. And then I can add 18 to both sides, and we get 2x is less than 20. And when we divide by 2, I get x is less than 10. So here's my first bound on the range. Next, if I take a look here, the smallest angle, I always want to look at the smallest angle because that's how small I can get. That gives me the lower bound. Here's 42, which is the smaller side. So I'm going to go ahead and use 6x minus 18. And we know that this angle has to measure greater than 0. So here I'm going to go ahead and add 18 to both sides. And I get 6x is greater than 18. And then when we divide by 6, I get x is greater than 3. So now I can write my inequality and say that 3 is less than x is less than 10. Here's the range of values for x.